Hello and welcome back to module number 4. We are going to continue our introduction to Python, but in this time I'm going to do a little bit more intensive module than I did in the past, because we're going to cover 4 important things that, again, for me was the foundation of Python. First, we're going to talk about the concept of data types. How do we distinction them? What does it entail? And I will explain that in 2 seconds. Then I'm going to talk about numbers, data, and times. And then on the third part of this presentation, long presentation, I'm going to talk about how to read files. And then the last objective is the idea of how to separate or to isolate part of the container in order for us to find specific type of value in the data that we are interested in, and I will show you how to do that. So let's begin, and I hope you enjoy it. So the first thing, we are going to learn how to use, again, I am a mathematical guy, so we are going to learn how to use the library that Python has in order for you to do that, and I will show you how to apply that. But in order for us to understand, we have to understand how the program patterns in Python works in order for us to run it. And so we will need in module number 3, in part of our objective is we will learn how to write a program and how to process numerical data. And this is a good starting point for me, because type of data is really problematic, because Microsoft Excel accepts the data, but it doesn't allow us to differentiate between the type of data and what it represents. And so the idea here, there's 2 types of numbers: whole numbers and factorial numbers. And how do we make distinction between them? So the idea that the factorial present a different value in compared to factorial data. And so the idea here is that the data type of an object determines what value it can have and what operation it can perform in order for us to run it. And so the whole number are represented by integer. In short, it's called int, and it represents the data type. And this data type can be positive or negative. But we also have the idea of factorial parts of the numbers, which in the Python called floating or float value. And so the idea here, how can we define a floating? 0.02 is a floating number. So let's try to understand how we let Python decide for us what type of data is it include. We will type 3, and he will say this is class integer. And if we will type 3.1, he will say it's a float. This is how we will need to accommodate ourselves in order for us to import data, in order for us to analyze using the Python. So why do we need 2 types of data? Usually we cannot values that represent 3.5 quarters, it cannot be captured in Python. So that's why the floating is the idea of, that's how the majority of mathematical models are integer. Most mathematical models are working in computers, and this is how we apply to it. We do not have 3.25. It doesn't exist. So the float type store the approximately to the real number being representative, and that's how we're going to do. But since floats are not exact, we will use integer whenever possible, and this is important. So example, we have 3.0 plus 4.0, it will give us 7.0. And so this is part of how we're going to be treated when we're going to apply or bring it to Python in order for us to do that. So this is important for me to point out for you that integer division produces a whole number. So that's why 10 divided by 3 is equal 3 by the power. So, and since this is how we calculate that, this is what it will remind us. And again, we have always how to apply that and how to divide it, and we using the math library. And the math library, again, beside the abbreviation that we can use in Python, we have a lot of functions that can be available in the math library. The library is basically a module with some useful definition and functions. So when we're using the following formula, and this is the standard deviation formula, and so standard deviation. This is the basic formula that every statistical course, probably you encounter this formula. So the problem here is that to write a program to compute root equation is a problematic. So what we have to do is to use the math library in order for us to do that. So we use the library to make sure that this line in our program, import math, is embedded in order for us to run it, in order for us to use it. So how do we apply that? We will write a line saying math dot square root of x in order for us to apply that, and it will use the dot notation to tell Python that the square root function found in the math library module in order for it to do that. So if we want to do a little bit more advanced statistics or advanced calculation of the root, we're going to use a little bit different approaches of how to apply to it. And again, this is the math, the idea definition main, and I'm going to say print this program find a real solution, and print, I'm going to leave it empty, ABC, and it will be if input, enter the coefficient, and I will going to say this is how apply in order for us to find that the main basically is the following solution in line number 3. So what is what do we need to, why do we need this? What is the idea? We can apply also the idea of applying files into it in order for us to do the square root or to do the calculation. It might be sometimes problems. I will help you to overcome that, but this is, I want you to keep in your mind that some of the things you see here can be applied. So the math library, when we try to make square root of a negative number, again, the square root function is more efficient than using triple multiplies. So you can use this triple multiply to calculate the square root. So again, this is how to do that. And so when we say in line, when we're saying that 5 people standing in line, how many ways there are to arrange the 6 people? So 700, and we will say is a factorial of 6, abbreviation of 6 power, and so the factorial is defined, and we will say that this is n square equal n multiply by n minus 2, 1 and n minus 2, and etc. And we will come up with to do that. So the factorial, we can write a program to do this input number to take the factorial of n, and so we will compute the factorial of n fact and output fact in order for us to come up utilizing, and there are a couple of reasons to do that. Each time we are going to go through a loop, and I will explain later on what is a loop and why are we using it. In fact, that we are using it and how to apply it in Python. So the idea here is that we can apply a fact is 1, and we can multiply it in order for us to define what it is, and we are going to apply that. So what about the range of return? 0, 1, 2, 3, and n minus 2, 1. So range is another way of optimize the range, which means that we can optimize the way how it display, and we can start and stop and plus step in order for us to apply that. But one of the things that I want you to show, and that's how I try to get there, is the idea of a list. It is a sequence to make a list in order for us to help us to sort things out. So let's try some example. A list range of 10, and it will give us a list of 10, a container of 10. And when we will ask, for example, a list with a range of 1 and 5, it will give us that. Again, even though there's two numbers, the range is also help us to sort it out in order for us to do that. And again, this is the way for us to sort things out, to make our life easier with regard to how do we arrange the numbers, how to capture them, and how to apply them in order for us to do that. This is again factorial. Define a main, and I will go on to say n is equal input. Please enter the whole number as fact is equal 1 for factor in range n 1 and minus 1, and I'm going to say fact equal fact multiplied by factor, and I'm going to ask to print those value, and that's what it will come through. So the limits of integer, and what is 100 in the power of 100. So main, we are going to say please write the whole number of 10, and it will give us the value instead of you doing it manually. So that's it. That's the party of a big number. And there is also I need to point out there's a little problem with in integers. And so in this case, I gave you an example and ask you to do, and he will come up with integer multiplication error, which is overflow. And this is part of us to understand the data, to understand what it is to do. So what's going on here? It is the infinite number of integer that is in a range of integers that can be representative, and so this range depends on the number of bytes that the CPU of the computer can represent. And so the idea here, we are limited with the number of the operating system, and in order for us to do that, we can overcome it. But again, this is just background without ideas. So heading large numbers, we can does switching to floating data types around us limited the integers. So we can use 1.1. We can get the main, enter and please enter whole number 1 to 15, and it will give us a factorial of 15, which is 1.30 blah blah blah. So we no longer get an exact number, and again we need to be careful with that, because very large, very small numbers are expressed in scientific notation, and we need to be aware of it and how to apply that. So again, this is just a warning. If you are into mathematics, this is something that Python does well. Floats of large numbers, again, this is something that we can talk about, but there is a solution to extend the idea of integers. And so the Python's integers are not fixed size and handle whatever the value it holds. So the new version of Python automatically convert integer to expand form, which they grow so large as the overflow. So this is something that I want you to have in your back of your mind and try to understand it. One of the things that we need to talk about is the idea of type of conversions. And the idea of conversions, again, deals with integers and how to convert them into a float. For example, what happens when you have a mix integers and float in the same expression? 5.0 plus 2. So what do you think going to happen here? So the type of convention is the idea that he will convert the 2 to 2.0 in order for it to do a floating point and add the two numbers together. So converting the float to an integer will lose information, which again can have an effect and can be applied. So the type of conversion is called mixed type expression, which is convert integers to float. And sometimes we can control the type of convention, and it is by typing explicit in order for us to do that. So this is again, I am mathematicians, so I'm really keen to it, but now to a little bit more easy side. Files and how to deal with files, how to read the files, and how to apply them. In this section of the notes, you will learn how to read from and write to file names. So the idea that what you need to, in order to read information from a file, you need to have an open file, an association file with a file variable. So the command to read the information and a command to close the file. So again, preparation for the file for reading. And the idea here is that you're going to call a file variable. You're going to say file, open, name of the file, and with the R. And so, for example, we can also input file, and you're going to search for data.txt in order for you to apply that. And again, this is example of all the files that can be open in order for you to do that. The position of the file pointer is also important, and this is something that we will need to take care, and we will need to be able to understand the idea of position. So this is the A, and we can point out to show us the A. So reading information from a file typically is done with the body of a loop. So in this case, the variable to store a string in a name of the file, do something with the string, read the file. So in this case, I can do example for line input file, I can print the line in order for you to do that. To close the line, to close the file, you're going to say input file and dot close, and it will close the file. So this is how to apply. I put together a little example of reading from a file. Again, letters.txt or gpa.txt, and you're going to put in it in order for you to do that, and you're going to close the file, otherwise it will keep on be open. When you need to write information on a file, you have to be aware that open the file and associate the file with a file variable the file is often locked. So the command to write the information and the command of closing. So the name of the file variable, open the name of the file, and this example, gpa.text, and I'm going to open the file, enter the name of the output to record the GPA2, and I'm going to change it. Typically, the file is created the same directory folder as the Python program. To write on a file of a text file is to open a file, write, and you're going to say temp in order for us to do that. That is, assume it will be a string of characters. So write a file, putting it all together, the name of the file, the output of the file, input file, print the file, and again the end result of it in how to do that. So for line in input file, if I can write it as the if condition, if, else if, in order for me to have the entire experience with that idea. Try to see if it works, see if it applies. You need to have a file to be open. You need to make sure that it is on the same settings as your Python folders in order for you to do that. Again, the implementation of it and how to apply to it. Again, example of it. Data process files. Files can be used to store complex data that, given that there exists a predefined format. So, example, employee text, last name, and I can have first name, occupation, and income. And if I will do that in real time, I will say print, and I will say for the line input, I will say name, job, income in line split, and I will show you what it is and what it consists of in order for me to summarize my data in it. One of the things that I'm really concerned, I did not show you that in real time because I was afraid that my system will crash. So no example, I will not run Python in this module because one of the things that is happening to me all the time is error with the idea that we cannot explain. So typically those fatal runtime error, crash the program, happens, and typing the open and non-existing file is part of it, and I want you to be aware of it, be aware that it can happen, and try to be calm about that because you can always close it and rerun it again. Expectation file, again, one of the biggest problem, as I said, name of the online example file, expectation.ph, input file, and I will say most previous input files can be used is input1.text, and in this case I will try to bring it up in order for me to do that, and it will finally true in order for me to file input. So those are the examples of expectation validation PI, and I'll post it in your Canvas with this presentation, so you will have a sense what it is entail. So again, how it will apply, and enter the number, again what it will. So you should by now, based on this presentation part 2, you should know how to open a file for reading. You should know how to open a file for writing. You should know details on how information is read from the written to a file. You need to know how to close a file, and why is it good practice to do that explicitly. And you should know how to read a file from a big file, and it's the same process as I showed you before, and apply it. So summary notes, again, we can do a F dot file text name in order for you to do that, and be able to with a constructor in order for us to do that. The other method is method of open, and you can do that in usually it's quite often useful and quite easy to use. So there are a few steps to grab into file from a file. So f.read, f.read line, loop over the file object, and this is the example that I post, example of how to apply, and so you will have a standard way to do that. Standard files object, just as C++, Python has also standard file object for input, output, and error in the system module. So treat them like a regular file object, and so the input, the system, for line in is the system admin, and print line in order for you to do that. Output is again print or print with a quotation in order for you to apply. Print function, again, we can apply the print function with a little bit more complex. In this case, we can multiply by the objects, by the month with the end in order for us to apply it to make more argument or more profound understanding of the file itself and how to apply that. All those file output, I'll show you example. I gave an example on Canvas, so you'll be able to understand what it is entail and how to apply that. Handling is also part of it, and again, I will show you more example of it on Canvas. I want you to go over that, and again, this is try expect clause option as follow: expect name, accept name as value, and part of how to run it and how to handle it. And the Python actually analyze the data for you in order for you to do that. You can also create expectation by using the following code, and again, assertion is part of the equation, and the textbook talk about that quite often in chapter number 4, and so I want you to go over that and to be sure that you understand that. When you have a CVS file that you want to input, example football, and a lot of students already came to me and said we want to create a Python program in with football. So the idea is that you're going to say input CVS, you're going to say with open example the name of the file as CVS file, and you're going to say read CVS, and it will be equal CVS.read the name of the file, and you're going to say print row with conditions and how to apply that. So again, the last subject that we need to talk about is the idea of what contain for the objects, so you can loop over the objects. In other words, you can run for the loop over the object. There are many ways to do that in the standard library. For example, list can be done that. So for I in the container 1, 2, 3 print, and it will print that way. When we use a string, it loops over its characters, and in this case, the CPython will do that for us. So he will bring down the idea of it. You can also use a dictionary if it loops over its key. So example, K, which held a container of two types of data. One is the X and Y, and one is numerical 1 and 2. So in this case, I can break it down in order for me to do that. So there are many functions that can be used in order for us to do that. And again, example of it, join, and I can apply to it. I can break it down to x and y and 2 and 1 and 2 in order for us to do that. And again, this is how I do that. The idea here is that each time we call the next method, this idea of integrator give us the next element. So if there is no more elements, it raises the idea that we are running into a loop. So this is part of the idea, and this is part of the presentation. I know it's a little bit hard. I did not cover everything I wanted. I do apologize. I will give you more insight to all the terminology and all the example I provided in my PowerPoint presentation. I hope it makes more sense when you go over the PowerPoint and my record, my video and the notes that I'm going to post. I hope it makes sense. Let me know if it doesn't, so I will try to come up with new ways to display that. But until next time, enjoy and have fun.